Hi, everyone. Welcome to the new season of the webinar. I'm Gil, and thank you for coming today. We're going to talk about TDD in legacy code today. Well, the legacy is not just for today. The legacy is for everyone, all the time. And just want to remind you, while I'm going to talk, you can write things in the chat, which I probably won't see, but I'll hope to get to it later. If you have questions, though, put them in the Q&A box. I promise I will look at them later. Not sure if I promise to answer them, but I'll try to do that as well. What else do we have to say about TDD? Well, it's 3 letters. Okay, so I'm going to start right now and see how this goes. Click. Yeah, that's me. Okay, so before we start, I'm going to talk about my favorite subject. That's me. I'm Gil. I'm a consultant. I work with developers, testers, everyone who's work on software and sometimes even hardware, who want to be better at their job, develop better, test better, product better, and other verbs I just invented. I'm the author of 2 books, Everyday Unit Testing and Everyday Spring Testing. And obviously unit testing is going to be part of what we're going to talk about today. You can contact me at gil@testinggil.com or on everydayunittesting.com or testinggil.com, which leads to the same point. You can catch me on Twitter and other things of social media. You can follow me. Basically, this is the first of this season's webinar. There's going to be one every month. And we're going to talk about TDD, like today, testability, clean code, things in the testing space, automation space, everything that I actually like to talk about. So let's start. Oh, no, let's not start. I'm also doing training and consulting around this topic. So if you want to know more and afraid of big bugs like that, contact me. That's me on the left, getting by the bug, or Tal, my business manager, tal@email.com. That's not her in the picture. Before that, we'll see how many books will roughly at the end. But if you stay until the end, you're going to be eligible. I'm going to do some raffle for a license of the Every Unit Testing box. Now we can begin. So TDD, these wonderful 3 letters. Basically, why is this session? Why do I like to talk about TDD? Some of you probably know. I think it's the best way to program. But a lot of the pain involved in TDD is when you start looking at it and you read about it, and basically you see these kind of pictures. Let me go through an example because that's what everybody does, and it's going to be a calculated example because that's what everybody does. So you start with red. Red means you write a test, it fails because of anything. Like it could be like the code doesn't compile, the logic is not there, even an earthquake. But then you write the code to make the test pass. Actually, you make all the tests that passed until now pass. That is considered green. One test and all the other red is not considered green. And once you have this, you have like a safety net of tests. You can refactor what you did, and what you did includes both the code itself and the tests that you have until now. And you look at this and say, well, this is nice, I can do that. And then you look at the example, it looks like this. Obviously, it's always a calculator examples, testing something that the Java compiler does for you. But anyway, so you create a class, and you don't create a class, create a test. It's called calculator. It has nice red lines underneath it because the class doesn't exist yet. It doesn't even know to complain about the add part. So what you do is add a method and suddenly the code compiles, and you have code that actually tells you that 3 plus 5 is indeed 8, so we're green. And then you say, well, I and j are cool names for parameters. I want better ones, so you refactor and you call them first number and second number, and the whole world becomes brighter and pinker and everything's fine, and you move on to the next test. And you say, well, this can't be that easy, but unfortunately, it really isn't, unlike my spider folks here. When you come to your code, well, the real world happens. So you find it very quickly that the examples that you see are very simplistic. And while you try to understand, usually what people gather is the red-green refactor parts. They don't see how they can do that in their code, because if they will actually do that, you'll see that test writing becomes very hard. Then you'll have like passing the test will come very hard, because we have all kinds of dependencies. And when you write a test, it won't run because it has like 5 other dependencies needed just to get over to the code that you need. You need to create like this bunch of data just to run the code that you need. And I wrote here the code resists, but it's not that the code really resists. It's us resisting. But you have all kinds of, you don't have tests. You want to do that. And you see this bunch of code just looking at you, and you say, well, I'm not moving. Are you going to move me? And it's risky to move code around. It's not easy. It may be simple looking. It may be like, sorry. It may be like refactoring using tools, something like that. But this code has been there for 5 years working, and are you going to be the one who's going to change it without the tests? Because you have a nice thing you'd like to try, like TDD that you've read about on the internet. So it is risky, and that's why a lot of people don't do it. When they take the examples, take it into their world, it's hard, it's risky, and people tend to say, well, it's probably nice, it's probably working for some people, but it won't work here. Something I mentioned before in another webinar, what we want to do really is produce code that works all the time as quickly as possible. So without refactoring, without moving code around, without writing tests, we tend to make this, our job, really harder. And we actually want to do this. So while the code resists, yeah, this is kind of a situation 0. This is where we start from, but we know we don't want to be there. And TDD would be a good way to get from this kind of thing to actually getting to a situation where we can do this over time. But it doesn't seem like we can. So today I'm going to show you a couple of ways that you actually can do that. Now, you're probably thinking, how do I do that? So, and the idea is that you have to start thinking a bit differently and stick to a couple of principles. And these kind of principles are what will guide you. And the first one would be like thinking about, okay, I want to write a test here. How do I know I'm going to make changes? Well, TDD in legacy code. This kind of change would be like either fixing a bug or adding functionality. What else do you have to do there? All other changes are really refactoring. And we're not talking about them yet. So you're going to do a change. How would you know that it worked? And this kind of testing thinking is not something that we're born with, or when we talk to program, we will learn to ask this question. Well, obviously, I'm going to run the system and debug it and see that the right parameter works. But when we're testing, we like to expose what we want to do. So first thing, ask the question, how do I know that it does work? Sometimes the answer is very easy. Sometimes the answer is very easy. I'll look at the logs, which is not good for a test. And then you might need to do something. And sometimes the answer is, well, we don't have a way to do that. And if that's the case, we need to do something in order to expose this thing out. So the first thing to do is just ask, well, if I check this thing, how do I know that it works? Once you do that, I'll show you in the examples I'm going to show you, add a couple of tests. Now, when I'm saying adding tests, I'm not saying just the TDD cycle, but if you want to be like in a safe place, you want a safety net, you want more tests probably than the ones that you have. And we're going to talk about characterization tests that will help you. And sometimes adding more tests that you actually think you feel, or just not just beyond adding the code and the tests that need. We're going to do refactoring. Now, everybody knows, everybody, even on the moon, that refactoring comes after you have tests. But if you don't have tests, and remember my first question, how will I know this will work? Sometimes it's not that easy, and you'll need to do some refactoring before you actually enter the TDD cycle. I need to say something about this. I'm saying a lot of TDD, but what we're going to talk about may not look like proper TDD. It's not may not be the cycle, but the principles that we do take out from TDD, applying them, especially test first, but factoring, refactoring under tests and so on. So let's getting back to, sometimes we do need to do some pre-refactoring before we actually do this, and I'm going to talk about that as well. And after you do that, and then you add the test and add the code and refactor, you can do this more and more and more. You're doing TDD, basically. And like I said at the beginning, TDD is a programming method. It's a way to write code. And when you do that, what would you do tomorrow? Write more code. How do you do this? With TDD. I'm going to show you a couple of examples. One of them is adding a bug. Okay, adding a bug that doesn't, fixing a bug better, maybe better. So adding a bug fix. And the other one is adding a feature to existing code. Obviously, I'm not going to show you like a whole application here because this would be a while, but I hope the code that you'll see, the principles still apply. And the way I'm going to show you is with my messy calculator. People who have been to my webinar and workshops might have seen this before. This is not how you build a calculator, but somebody actually did, apparently. But we're going to do this from the inside. Our calculator example basically is two APIs, two methods. And I'm going to show this at the unit test level, but what I'm going to show you applies at any level. It could be like API test level or end-to-end or whatever, because the principles are still the same. So yeah, so let's take a look at our code and do some demo. IntelliJ, so what does my calculator look like? Like I said, it has a couple of methods, press which gets a key, what I pressed on. And you can see right here that it has, it is incomplete in terms of functionality, but that's good because like I said, my example would be to add functionality to it as well. It has support for plus and division and equals. Doesn't have multiplication yet, for example. Also, it has some kind of division by 0. So you press stuff. It has C for reset, for example. And it, like I said, it has the press thing, and it has a get display method, which shows you what's on the display panel. Like this. And that's the only interface that we have. And fortunately, it's the only interface that we need. But as you can see from the code already, that adding stuff in will either do two things: either make it more ugly and or make it more risky to add more things as we do that. So where do we start? We start with an empty test. Don't have any test. Now, I said at the beginning, I want to do things safely. And I do that by adding characterization tests. So I'm going to show you. So I'm starting without any test. I want to see how my code behaves. Characterization tests help me do that. So imagine the situation where you have code that works for 5-10 years. Nobody touches it. It's perfect. It's ugly, but it's perfect. And no, there's no documentation of how it actually should work, but it does work. And you don't want to break anything. So what do? You start poking at the system and see what comes out. Luckily for us, I made luck happen. We have an interface to both operate the machine, the press method, and the other one is the retrieve information from the machine, get display. So you can see here I'm creating a calculator, and at the beginning, I'm calling get display, and I'm getting 0. So I'm kind of learning that if I at the beginning, just call get display, I see the 0 there. And then if I press something, I see something else. And this is a characterization test. I put the asserts in because this is what I expected. But if you're actually poking in a machine, you don't see, you don't know what to assert. You're going to check what get display actually gets you. And then you say, well, this is how the system should be. And therefore, you write an assert for that. And you continue to do it. And I continue to do that because last time I actually messed with this calculator, as I created, I think like 4 years ago, I actually forgot what actually works and what doesn't. So I'm adding more tests. I didn't touch the code at all. And I did something like this. I have the add start, should show, and pressing, which are internal method of the class, and you can see what I'm actually doing. So it started choose 0, pressing C should add 0, pressing 3 plus operation after a number doesn't change the number because this is a calculator from the 90s, like I showed you. It doesn't show you exactly what's going to happen. It doesn't show you the future. So it has some kind of rules, and I tried all kinds of things. And some of them worked, and some of them don't work. Okay, and these, what you see here under the failures, I kind of collected them into what doesn't work, are things that kind of surprise me that this is how it actually doesn't work. So at the beginning, when I'm pressing plus, I'm expecting to see 0, but this doesn't happen. When I press 0, 3, I want to see 3, but this doesn't happen. Now, what I can do with them, I'll show you in a minute because we're going to fix a bug in them. But I'm going to continue going through this code because I want to show what else. I found out there are things that do happen, like this 3 plus, pressing 3 plus and plus actually returns 3. And I was asking, well, should it actually work like that? It does now, but this is something that I can discuss in terms of requirement behavior design if I actually want that. But this is like I collected into these kind of things. Obviously, this doesn't work. You can see also the method that I did, the utility method pressing at start and the expected. Notice that the pressing thing starts with C because I could put every line of them as in a separate tests, but the system is not complex enough, and I basically can gather what's happening here. And all the strings that I'm putting, it's like it kind of sends press with every character and shows the get display. And that's basic and should show asserts and that. So step one is like adding tests to the system. Here, it was very simple. If you have API system, it will take your APIs, it will probably take you longer, but you might need to expose stuff. But you need to decide at what level you want these tests, because even if you're at the API levels and you say, I'm going to change something inside my service, maybe I'll put a unit test around this service and check at that level. And maybe the API will be documented, but the service will not. So you need to add this characterization test. But whatever thing, these things are going to continue with me because they will be my safety net for the next steps. So yeah, I added tests, rest really easy. So I'm going to look at this thing. So like I said, the bug we're going to fix is press plus on the beginning, and I'm expecting to see 0. Because if I run it right now, it will break on the first test, obviously. Yeah, yes. And you'll see that the first thing that happens on this is that I get an internal exception. Obviously, we don't want that in our 90 scan. So this is the bug we're going to fix. How are we going to do this? TDD tells us add a test first. So I'm keeping my successful characterization test. I'm with the utility methods. I'm adding a test here. And I actually copied into that, into the bug fixes test, the utility methods. So I can write my test here, which basically look, pressing plus should show 0. That's done before. How do I solve this? Well, looking at the code here tells me that, well, the problem is this. Usually when I try to solve a bug, I actually look at the code and see what's happening here. And at the beginning, the display is empty. When I try to parse an integer called empty, there's going to be an error. So obviously, this is a problem I want to fix. How do I do the simplest thing that actually passes it? I will go to the fix part, and you'll see that I added an if here. Otherwise, everything's okay, right? So now I have a working test. Let me just show you because you might not believe me. Yeah, everything's cool. But then I look at the code and I see, well, you know what? This will work for the plus. But you can see I have the same behavior with division and equals. So each one of them is going to be a problem. So I want to really fix the bug. How do I do that? TDD tells us first write a test. So I'm adding these tests, and then I'm adding this code. Remember, now, is that really TDD, like in the books, like step by step? No, I wrote the tests, they failed, and then I added the if to all of them, and now I have all 3 tests passing. Cool. What do I do now? Refactor. How do I refactor? Well, obviously, I now have this thing here repeated every time, which kind of increases my error level of the code. And we obviously don't want that. So we can do all kinds of things. What I decided to do in order to refactor is create a parse key number. The original if that I passed was here, right? I wouldn't go into the condition if both of the conditions were right, but I can do this check here. So if I go to parse key number here, method I created, I'm checking if it equals 0, if the display equals 0, just return 0, and I won't go with the parsing, and only do parsing if something was there. My tests are still passing, which is very cool, excellent, and I'm finished. Am I finished? Well, remember, refactoring is not just for the code. So I now have the characterization test from before. And the bug fixes which I created, which bug fixes, yeah, have 3 tests. And like I copied here before, so it's no surprise that the utility methods are still here. So I can refactor the test as well. I created a base class. This is one solution to do it. I'm not saying it's the greatest one, but it's something that people do. So I created a base class with a utility methods with the pressing, show, and start and should show. Creates the calculator. We call it base calculator test because it's only needed for the calculator. For other classes, I'll use another thing. And now I have both the characterization tests here without all the craft from before. And I renamed the bug fixes to calculator start test, which is probably not very good English, but it tells me that these are things that I want to check at the start. And then it kind of shortened the name because before it was when pressing plus should show 0 at start. And that's cool. Now I have a bug fix. I have removed the application. I refactored. Everything's cool. And that's it. And now because I've done such a great job on this, my boss tells me, well, why don't you add a feature? You know, we want the same behaviors for now, like you had for the plus and the division. We want that for the minus as well. How do I do that? Okay, so let me check and just close this thing and move on here. So this is where we at. Now, let me just close the other stuff. We have too many things open. So this is where we are. We have the parse key number, we have the characterization test, and this is the code. Now, obviously, I can do like another else if here in the minus. It's like telling me just do this. But obviously, I can see that yes, I can do that, but it will make the code worse. Plus, I already see a repetition here called application that I will probably want to remove. It's an opportunity to make things better. So my goal would be in these first steps is to make it easy and less risky to add code. So I'm going to do a couple of things. My first would be to deal with this. Now, I said we have a name for this pattern. It's called error code, anti-pattern really. It's called the code smell. And because it goes from the left to the right, it's like an arrow. And if it was just an arrow, that would be great. But it's a jaggy arrow because we have all kinds of blocks here because it's indented, goes back and so on. The problem with error code is when you actually go to when this happens, but you actually at the end of the arrow, where you already forgot what kind of conditions you had to go through in order to get them. So the code really doesn't tell you or tries to confuse you. That's what legacy code does, confuse. We want to make it better. So first thing that we do, I'm going to use a couple of refactoring patterns. All of them are kind of inherent in every tool that you use, like IDE. It's in Eclipse, in IntelliJ, Visual Studio, whatever language you're actually doing. And the first one is introduce guard block. And basically, if you look at the code, I have the if else and nothing else. So the code does either if or else. So what I can do is replace this with this code. So if somebody presses C, I'm setting display to an empty string and return. So everything after the else moves indented to the left. And this is a method to remove a lot of disarm errors, let's call it, because it helps. The more conditions that you have and more complex conditions that you have becomes a bit risky. But for introducing guard blocks, most tools do this very nicely, let's say, safely. Remember, I still have all the tests that I have until now to tell me that that's okay. Now, the next thing that I see is that, yeah, from now on, I can't really introduce guard blocks because after the if and else's and stuff like that, things still happen. So I can't do a return early, not immediately. But it does shout at me, Gil, use a switch case. Don't do the if else's. So that's what I'm going to do. So from basically the plus, the division, and the equals, I see that as a switch case. And I see in my mind that if it was a switch case, it would be much easier and a good idea to, when I edit, to have this. Now remember, I haven't added a test yet. I'm doing a pre-refactoring based on the test that I already have. So I need a good safety net of tests to do that safely. Transferring or just transforming if else, the complex if else, to a switch case starts getting into risky land. Again, the tool will do this for you, but tools are smart up to a point. So I saw sometimes IntelliJ getting confused. But it can also be confused on renaming. If you're renaming something to be the negative of what you actually did, the compiler doesn't know. So it will just confuse you more. So you can trust tools up to a point. So how does the code look like this after the switch case thing? Oh, much better. So like I said, I'm taking the arrow and take it back a notch. And now the application actually stares in my face. So right now, if I do the case minus, I know exactly what I'm going to do. I'm just going to copy these things again. But am I going to do that? Absolutely not. Why should I copy stuff? I'm going to extract the method first. And extracting methods really is the most, apart from renaming, the most simplest and safest thing you can do in terms of tool. I had added a handle op key, which is this method. I'm passing the operation type, the enum of what I want to do, calling parse key number. I already observed the application. Why should I do that? And the code looks better. And now I can actually add very simply the case for minus. Do I do that? Of course not. I'm going to add a test first. But it is going to be very simple. So I have my calculator start test. Obviously, this is not a start thing. So I'm creating another test class. Number after minus should still display. Pressing 9 minus should show 9. And now I have my base calculator test that I created before, so it's even easier to write tests. This obviously fails because I haven't written the code for that. So I'm adding the minus. And that's basically it. I added new functionality with the simplest thing that works because I actually worked towards it. I could have written the tests before I started refactoring, but then I would have like a failing test all the time. And that red would tell me, well, something's wrong, something's wrong, something's wrong. And because I know where I'm going, my mind would answer, of course, something's wrong. Because I wrote the test that I haven't written in the functionality. But then if something would break because I've broken something else, I wouldn't have noticed. So I'm separating refactoring from adding new functionality. And that's one of the principles of TDD. The separation between adding functionality and just working on that, turning red into green, and refactoring, which is always moving code around while keeping it green. We see it as like the last simple thing of TDD, last part of the cycle. But when you actually think about it and you can invoke that in the way you work, you're actually being able to focus on small things and like clean everything out and focus on that. And now I've created a diversion. What kind of refactoring? So these things, handle op key, make sense. But because I know how calculator works, because I'm smart, I'm actually already segregated parts of the keys to different groups. So I have the operation keys, like the plus, minus, and the division. Equals is a bit different, both because I look at the code and I see that it is different and I know what it does. So it's not an operation key like the others, so it's probably not going to be the same code. And I have the default, which is basically all the other stuff. What are all the other stuff? Well, numbers, of course. Although with an asterisk, 0 doesn't always behave the same thing. Now, you look at the code and say, well, I don't understand what it does. What should reset and stuff like that. New argument. It's complex. And yes, you can dive in and do that, but let's make the code still easier to read. And now it contains two types of languages, high-level languages and the low-level, that's the details of implementation. So let's change that. Let's refactor that. So all I'm doing is just extracting methods. And now my press method looks like this. Handle op key for what we did, handle equals, and handle numbers. And you can see that this speaks the same language. It's no longer an arrow. I can definitely see what it's doing here. I can work from here. I can add the multiplication very easy. If I need to do something with numbers, I know where to find them. And the code is much more easy to work with, as well with the tests, because my tests are still nice. And that's basically it. You can do these things all the time. The principles are there. Simplicity, that really depends on what we're doing. So let's summarize, because we want to finish and move on to your what's that? Yeah. So yeah, finishing touches, let's summarize. What are we doing? So the main thing, the way we're doing that, we want to maintain whatever worked before, still keep working. So we're always thinking, how do we minimize risks? The answer to that usually, add tests as much as you can. Learn about the system as much as you can. Refactor in very small steps. Invoke the tools when you trust the tools. All these kind of things minimize the risk when you change in code. And when you start trusting in the tools and the process, you'll be much more motivated to do that, and then the code will be better anyway. Then you think about the code itself and how to make it better. Better for you before you add in code and you add the stuff. And after that, that's the refactoring part. Well, actually, the refactoring part is this. Because you actually want to clean stuff up. You want to clear up the area, move code around. Sometimes you might want to introduce interfaces so it would be easier to push logic outside and mock it. All kinds of techniques that will help you look at the code and say, well, I'm going into this kind of space. I want this to be clean. That's basically it. These are the principles of TDD that can be applied to everyday situations. I can tell you that bug fixes, I have fixed like that for more than a decade. I haven't stopped. Understand what's happening, write a test first, don't even call it TDD. Write a test first, write the code. If you have enough tests, you can refactor. Basically, this slide should have come up before I gave the last part of my speech. So yeah, it applies to everything that we actually do, and which is basically fixing the bug and adding functionality. And we do it over and 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 over again, because this is how we write code. This is how we program. It's very easy and it's much safer to do it this. How do you approach big legacy monoliths where single functions perform many business flows? Well, I usually try to extract the bit of the code to a separate function and then test that in terms of a unit test. Again, I'm kind of a trusty person in terms of method extraction. Now, if that's possible, great. If that sometimes it's not enough. Sometimes it's going to be a private method. I need to make it public and get shouted at, and why are you doing that? Sometimes I need to extract things in order to mock them, in order to get to the part that really interests me. So I'm trying to do the pre-refactoring in order to move things around so I can actually test it in what I actually want. It goes back to the first thing I talked about today, which was, if it works, how do you know that it works? So if it works, define what it does. So if it's this bunch of code, and I'm interested in this part, first thing would be like, how do I run this code alone? And sometimes it requires like pre-refactoring, moving stuff around. I try to do it with as much as safely as I can, which is usually by using extraction methods. Sometimes it would be something a bit more complex, like, yeah, put it behind an interface, so actually mock it. Like Java, I can't mock. I don't want to use any power Mockito, so I want just one, and I have a static method that creates a problem for me. I put it behind the interface. Sometimes something happens in another thread that hurts me. I'd like to isolate my code from this part that runs asynchronically. So I want to run my interesting part synchronically. So I'm going to move stuff around and abstract it and maybe mock it so I can concentrate on what's important to me. If it's everything that I want to run, then this is a big problem, but I'm going to treat it the same way. I'm going to create everything in order to run this bulk of code and see what's happening. That's a very big answer, and for the people with very ugly legacy code, that's really what you want to hear. But yeah, that's it. Tamash writes, it's not a question, more of a feedback. Our problem with TDD or unit small tests in legacy code in general has always been more about mocking and stubbing to have testable code in the first place. Sometimes the method do just too many things and also make it hard to write even the first test before we can refactor. Yes. So going back, sometimes you can't write a test that works what you actually need. And then you let me give you the first option. First option is to say, well, don't write a test. What would you do now? So you'll add the code of where you actually want to think about when it's actually do the changes. That's cool. Now, if you're going to do that, let's think of how you're actually going to test it. The code resists, but basically it's us resisting to write all these kind of tests. And it's a matter of my motivation and time and effort and money. So if we want to do a professional job, we'll take these principles and apply them. If not, we're going to do some kind of balancing act between thinking, well, I want to keep something working. Well, will manual testing prove that it's still working? Yes. Then I won't write an automated test. Is it still good enough for me? Maybe not. So I'm going to add a couple more tests. It's hard to add unit test. I understand that. Maybe an API test would be easier to write. Not sure. Sometimes it's not the case, but sometimes it is. I can't really, all my methods or all my APIs write things to the database, and I don't have access to the database. So I can run things, but how do I know that will actually that they are actually working? So I need to introduce some code that will expose some stuff to me. Maybe risky, maybe helpful. I don't know. But we need to start thinking about the code as something that is something that we're going to change, because we are going to change it. So if we're going to make changes, let's see how we can do this at this point that we have towards something that is A, safer, and B, more, that we leave it safer to do more changes as well next time. Next question. Does unit testing imply no encapsulation? Unit testing doesn't have anything to do with encapsulation. Unit testing is about proving that your code works. If your code is encapsulated, you've encapsulated it perfectly, but you don't have tests that prove that your code works, then your code is basically a gamble. If you need to change it to prove that your code works, then you'll have another code that works with proof. I find it better than having code that is perfectly encapsulated without any proof. So it doesn't mean anything about no encapsulation or with encapsulation. It does when we coming to talk about what do we leave behind, when we like to leave behind better readable code. And how do we do that? By refactoring. How do we know that it's readable, maintainable? We get someone else to review our code. But at the end, the test still need to pass. And the test need to prove that the code works. Another question by Leonid. How do you sell pooling methods to public? Oh, so yeah. For people who are actually zealots about not exposing stuff, it's going to be very hard. But ask them this. If you pull this method, what happens is usually the discussion is, I'm going to extract this into a method, and this would be a private method, which obviously would be a private method because I would have made it public otherwise. And why should I expose it? And my answer would be, well, let's say that you've already made some kind of thing that this should be separate from the method that calls it, right? So there is some kind of too many details, it's a bit more, it does something specific. What happens if you decide to move this method into a separate class? If you move it to a separate class, you might put it as a public thing. Now, how is public there okay than public here? Sometimes it convinces people. Sometimes it doesn't. That's how I try to sell pulling methods out. How do you approach stakeholders in the business to squeeze test development into a project that primarily aims at new features and value perceived by the customers? Oof. I can't convince you to write unit tests. I tried, it doesn't work. What convinces people that this is a safest way to create something that proves that I've done something that works. And it does so over time. So the business thinking should be like, my job, you're paying me as a developer to produce code that works, and you're not you're not paying me to do this just once. So tests, automated tests, is the best way that I know. TDD is the bestest way to do that over time. So if you want to release something that works with proof, and you want to continue this process and do it more quickly and more quickly and as quickly all the time, this is the best way I know. So it's not about writing tests or adding code to the project. It's about proving that something works at the end. Final question for today, because we need to fix this and to finish this up. So what are you suggesting is when you have a large monolith with little or no sense of layering, you create an interface, mock that, create a test, have tests passing by implementing the interface and move this. Like this, you are breaking down the monolith as well. The answer is basically yes. It sounds like you have like a small hammer and chisel, and you're trying to take down the mountain. And that's basically, that's it. What you're going to do is that you're not going to replace the mountain. Unless you do, but most people don't pay for replacing the mountain with something else that developers promise them that will look completely unlike the mountain, but may end up like the mountain. So what people are paying for is like doing this kind of thing smaller and not breaking everything. And the trick is to cut this thing out and just work on the small stuff all the time and improve as you go. Breaking down the monolith, parts of it at least. I'm not going to promise you that at the end you get a greatest microservices architecture. But yeah, this is how you create parts that are testable because they have tests. And when you have to change things there, it will be easier. Maybe you won't need to change things there because you have tested and proven that this code works. So I want to thank everyone that came here today. If you have any questions, can't sleep at night and think about, well, how do I fix my monolith? Give me a call. You can get me by all these things. The recording will be somewhere soon on the website. And I want to thank you again for coming today. And let me know what you think when it comes out. Thank you again for coming. See you next time.
Hey everyone, if you enjoyed this video, be sure to like, share and subscribe for more. Thanks for the support and remember, live long and test.